Good morning, everyone. This is Pallavi Khatri who will be presenting the research work that we have done on a survey on malware bypassing detection techniques. This work has been done by myself, Dr. Nimesh Agrawal, Yashasvi Saha, and Naman Shah. So, in this particular work, we'll be talking about the bypassing techniques that are used by malware to attack any system. So the abstract says that we understand what malicious softwares are. They come into your system and hamper your system's working. And lots of malwares are coming up. They are emerging nowadays, and they sneak into the system and take data from your system. So there are devices like IDS, IPS, and firewalls, anti-malwares, which are used to detect and verify that nothing malicious is hitting the organization. However, again, even after installing so many anti-malware softwares, still the malware come and hits the system and take data from it. So this particular thing we have covered. We have tried to analyze lots of data detection techniques that can detect the malware, and a comparative study on what malware detection tools or are actually to be used by should be used by any forensic investigator. So let me introduce you to the topic that as we understand that lots of advancement has been done in cybersecurity domain. Even then, lots of malware are coming up, and this is like again, as I reiterate, that it is bypassing the detection mechanism and it enters into your system. Even if you have installed some softwares in your system that can detect the malware, it bypasses all of them, right? So a number of malwares that are analyzed to demonstrate each bypassing. So we have checked for few of the malwares which are bypassing the techniques, bypassing the security mechanisms to enter into the system, and that survey has been done on all the techniques that can be all the malware bypassing techniques we have surveyed. So the motivation or the questions that came into our mind before taking up this work is, what are the ways by which we can detect the malware? What helps the security engines detect the malware? Are these anti-malware engines able to detect all kinds of malware? If not, what kinds malware are hard to detect? What are the traditional techniques used by malware to bypass detection? How efficiently were they able to evade detection? What techniques are being used by modern malwares and malware belonging to APT groups? Are there any legitimate programs helping these threat actors accomplishing their goals? So these are the points that we have taken into consideration while doing our research. So motivation is, according to AV test, there are millions of malwares emerging every month. They have presented this. This is the analytics of malware that are emerging. So it's impossible to limit the emergence of new malwares each day. Studying about each technique used for evading detection is still feasible, and so taking up malwares, especially advanced ones, and performing analysis on them will uncover the techniques it is employing to bypass the detection. The objectives that we have kept in mind, these are the objectives that we are trying to achieve. So research about the various analysis techniques used during the detection, discuss shortcomings of these techniques, identify the security gaps in these methods, research about how malware fit in these gaps, analyze malwares designed to evade detection, evaluate these techniques by their detection ratio, discuss each one of them providing supporting technical details, and compare the efficiency of these techniques, present mitigation strategies wherever possible. So few of the objectives we have presented in this particular article. So this is the literature survey that we have done. So from the literature survey, we have got few of the things. So as we can see that few of the articles, system like the first one that we have taken, system gets affected by any source, evade signatures detection, packing is used. To evade static analysis, polymorphism is done. To evade dynamic analysis, metamorphism is done on malware. So, and the second one that we have taken up is different techniques such as repacking, reverse engineering, and hex editing for bypassing host based antivirus. Signatures are illustrated. Bypassing HTTP, SSL, and SMTP malware defenses as channels are discussed. Finally, a new malware detection technique based on HoneyNet systems, which requires three different levels of honeypots, and its strengths and weaknesses were discussed in this particular article. Obfuscating malware using XOR techniques continue to be popular to avoid detection from antivirus, anti-malware products, and other network detection systems. That was discussed in this particular article by Cannell. For more advanced malware encryption like DES, RC4, or AES might be used. Then in next article where malware behavior analysis is done, they collected few malware samples, they identified their behaviors, they group it into different categories like worms or trojans or whatever, and then they perform some statistical it to like some statistics was taken into this, and where intelligence of humans was used to achieve the goal. Then again we have some heuristic based detection malware techniques that is being discussed by the next author. And obfuscation, control flow, data location, and data usage in order to evade detection was done by the Andres Moser. These are few more research articles that we have surveyed to, like in this particular article specifically, if we see that these malware detection or the detection was done on 5,000 malware apps, and the transformation that the tool is able to perform are disassembling and reassembling, repacking, changing package name, identifier naming, then renaming, data encoding, call in directions, code reordering, junk code insertion. And this is what we have done. The lab setup and technologies that we have used for our work is here it is. And then this is the methodology, all such methodologies which actually is used by malware to bypass the security system. So this we have done. First we have tried to implement the packer, XOR coding, certificate. We tested malware bypass on these particular techniques. So certificate bypass, sandbox evasion, anti-debug techniques, malware running itself in Windows safe mode, and furthermore. So this is the first one that we have tried to. So one of the most popular method is to employ the packer, where you pack like a tool that compresses your encrypts, modifies a malicious file format. So it will be looked at a legitimate file, and whereas it is definitely a malware. XOR encoding is done in that way that the first byte of the payload is XORed with the first byte of the key, and it's continued till the end. And when the contents of files are exhausted, then the password length is covered, then it takes a first byte of password again to do the XOR encoding. So then the certificate bypass, it bypasses the security certificate that is being generated by the system. So valid certificate signing and stolen certificate from legitimate file, that is one more method that your malware actually enters into the system. So the threat actors in valid certificate signing request for a valid certificate using details of company they compromised or of any affected front business. Then one stealer steals the certificate from a legitimate file, claims to have a valid certificate in the name of P-Reform, the makers of CCleaner and a self-signed certificate. Sandbox evasion, determining virtual environment through RDTSC, and contains code of long sleeps. Now this is what a specific malware that is actually hitting your virtual, even if we are in sandbox environment. We think that we are very safe, but this is not true. there are malwares which can bypass your sandbox environment even. Anti-bugging techniques, that is determining virtual environment through RTDSC and creating sleep gaps. These are the two techniques that help, or these two ways where malware can actually peep into your system. Malware running itself in Windows safe mode, if there are few applications which are not allowed to be active in safe mode, and that is where your malware takes a chance. So ransomware specifically is operating any disk in safe mode with the purpose of remote execution. That's how your ransomware is executed. Malware without malicious code, that is extract malicious code from another harmless website. So this is a chase. A banking Trojan gets the final stage payload from a block spot. Its script contains the command to contact the URL of a block spot and fetch the highlighted commented out code, which is AES encrypted. So this is how your malware without any malicious code even can just extract data using some coding techniques and can then hamper your system. Malware without malicious code, use of GitHub repo or Google Drive to fetch malware. This is what it does. Basically, they leverage the use of GitHub or Google Drive to download the payload. Right. So sysjoker employs the first stage dropper in the form. It's more like a dropper. Means you have a package software with a change extension or something, and then you use a dropper to drop the malware into your system. So analysis and discussion of our work is the evasion techniques that we have done, their detection rate and the impact on your system. So packing is detection rate is medium, whereas impact is low. XOR encoding, detection rate is medium, impact is low. Certificate bypass, the detection rate is very low, whereas impact on your system, that is based on the data, if it is taking or all, that is very high. Sandbox evasion, so the others you can see sandbox evasion medium, and that is impact is also medium. And again you have malware with no malicious code, detection rate is 0 and impact is very high. So these are the techniques that are being used by any malware to enter into our system, and we have done a survey on that. These are our conclusions. So what are the techniques that were used earlier by the malwares? And again, you have antivirus engines gradually starting detecting malwares using traditional techniques. Research involved in the study of various sophisticated malwares and ransomwares and methodology they use to bypass the detection. Malware belonging to APT group are highly sophisticated and has got higher success rate in bypassing detection mechanism as they are narrowly targeted. Most impactful technique found during the work was malware not containing malicious code, which secures almost zero detection. So these are the references that we have used. Thank you, and any queries are welcome. Thank you.